Thank you very much. Okay, so today I would like to speak on the topic of quantum computing and why you might really need to care about it. So, what is a quantum computer? Basically, it's this complicated machine that you see on the background, right? With a lot of wires and complicated structure. But let's get to something simpler. How often do you use this device? Well, I think we cannot live without our phones and laptops, with our smartwatches anymore. We need them because they are powering our lives. But think about it. Like before, maybe like 50 years ago, computers used to look like this. This is an ENIAC. And what was the purpose of an ENIAC? ENIAC was constructed to perform complicated scientific computations. For example, like for math or physics. And that was the main purpose. And now we have machines which are like that. I mean, they're 100 times smaller, they fit in our pocket, and we can like just enjoy using them, enjoy utilizing them, their full capacity and power, like Google or social media. But it started with that. And now, there are the quantum chips. The quantum chips. And actually, in fact, the quantum chip itself, it's small. It can fit also in your pocket. The thing that is the big is actually the dilution refrigerator around it. So you need a lot of architecture around this chip for it to work. But this is now. And we're looking into the future, such that we would be able to use these devices in our daily life. And it's going to be soon, maybe in a couple decades. But what would you use it for? I mentioned that the first computer ENIAC was used for physics and mathematics, for calculations. But let's remember the first computer ever that was fully functional. It was the bomb. The project of Alan Turing that was designed to crack Enigma codes. And it was used to crack the cryptography, right? So, in fact, the quantum computers can be used to crack cryptography too. And they can do it way more efficiently than the current computers do that. So, the quantum computers are a real threat to cryptography because they can open the crypto wallets like Bitcoin or maybe Ethereum wallets in a couple of months. And imagine your banking account being exposed. This is not what we want, right? But actually, the researchers from Caltech and the company Atomic announced that they developed the codes that will be capable of cracking the most popular techniques of cryptography in short times, as much as 3 months. So the companies are actually getting worried that the quantum computers will be a big threat to cryptography and our security in general. That's why Google announced that by 2029, they want to move to post-quantum cryptographic methods of securing your wallets and personal information. Because, yeah, the point is that you don't actually have to open somebody's wallet right now or open somebody's, I don't know, information. You can actually store the files today, and maybe in 20 years, having a quantum computer, you will be able to open all of them because of, well, they're ciphered with the codes that we have right now. And by that time, it will be easy to break them. That's why we need to urgently move to new methods of cryptography if we want our privacy and security stay in place. So, but can you use the quantum computers for something else? Something more peaceful, let's say. Something less dangerous. Well, how often do you use AI? I don't think that we can live without AI nowadays. We have it in our phones, when we scan our faces to unlock the phone, or for example, when we are chatting with the bots, right, like Claude or perhaps ChatGPT or Gemini. And the use cases of AI are widespread. But there is a problem with AI. It has a limited capacity for memory, and it's shrinking very fast. For example, if you ever tried to use a Claude, maybe, or OpenClaw on your phone, or perhaps your laptop, perhaps I think you would run into the problem that it would start forgetting stuff that you told to it earlier. So they cannot remember everything about you, which makes sense because they have only a limited amount of memory. But interestingly, the quantum computers can have a far larger memory for AI models. And that's a big advantage. Their memory is expanding exponentially with the number of qubits that you have. So imagine a model, a large language model, that can remember everything what you told it. Everything, all instructions that you told it before. It would be able to make predictions better. It would be able to answer your questions far better than the current models do. It is a powerful thing. And that's what we want to construct with quantum computers. And now you might question, how do quantum computers actually work, right? What is the base of the powerful technology? Well, the base is in fact in the concept of superposition. The thing is that the quantum computer does not have to be in one state at a time. For example, your computer can be only in one state at a time, or my phone, right? Like, it can be either 0 or 1, for example, like the bits, right? But the qubits, the quantum bits, they can be both of them at the same time with a certain probability. It means that, for example, if you wanted to explore the space of, I don't know, the computation, you wouldn't have to move from state to state to state to state to state to state. You would be in all the states at once with a certain probability. And then you could maximize the state that you want to be in. The state of your computation. The state of the desired result. There is one more powerful thing about the quantum computation. It is the entanglement. It powers the quantum computers. Because to execute the powerful algorithms, you need a lot of connectivity within the bits, with the quantum bits, right? On the classical computers, you have it too, because of your bits, your registers, they are wired together, so that information can be transferred from one bit to another bit, or from one register to another register. The same thing is accomplished in quantum computers using entanglement. But the advantage is that for the entanglement, you don't need a physical wire. The quantum bits can be entangled over a long distance without any means of communication. They would be just connected by default. And that's impressive. You can have a quantum computer, for example, somewhere in India, connected to a quantum computer in Washington, or perhaps China, just because of the connectivity and the physics behind it. And you wouldn't need a physical wire for that. And that's what leads us to the concept of the distributed quantum computation. That's a really powerful thing that will be essentially the killer app of the quantum computing, right? Because you are able to connect multiple computers in one network, right? It's possible. That's what we call internet, right? if you are connecting multiple computers, you can exchange the information between them. And you can do it too with the quantum computers. But when you connect them in a network, their power grows exponentially and not additively. Because when you have two computers and you connect them, their total power is just computer 1 plus computer 2. But with the quantum computers, it would be something like computer 1 times computer 2. So if you have n computers, it would be far greater than in the case of classical computers. Then what's the future? What's the future of the computing? We will be able to use the quantum computers in many applications, from cryptography to science, simulations, and AI. And it's the matter of us deciding if we want to be it peaceful or we want it to be harmful. So it's the matter of us deciding what we want for our future. Thank you very much.